Hey guys, so we're going to go over simplifying square roots. So the first thing that we want to talk about is what is a perfect square. So perfect square. A perfect square is any number that can be multiplied by itself to produce another number. So for instance, 2 times 2 gives us 4, and 3 times 3 gives us 9, and 4 times 4 gives us 16. And 5 times 5 gives us 25. Yes, 25. So these numbers right here in this column are perfect squares. Okay, so those you need to have memorized. So I always write mine out. So 1 technically is a perfect square. We just don't talk about it that often. But the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and then so on. Okay, and I would probably have those memorized up to about 13 squared, just to have in your bank. So these are the perfect squares that you need to have memorized. I normally write these at the top of my paper every single time I'm doing simplifying square problems. So now we're going to look at a problem. Okay, so when we're simplifying the square root of 72, I'm going to sit here and I'm going to think through my factors of 72. So factors are numbers that can be multiplied together to produce a product. So factors of 72 are 1, 2, 8, 9, 72, and there are other ones. But for right now, we're just going to use 8 and 9. The reason why I'm going to use 8 and 9 is because notice how 9 is a perfect square, right? 8 and 9 are going to be my factors. So I put these little branches out, and I'm breaking 72 down into 8 and 9. Now, can 8 and 9 both be broken down? Yes. So they can be broken down a little bit more. Factors of 8 are 4 and 2. Can 4 be broken down? Yes. Into 2 and 2. Can 9 be broken down? Yes. Into 3 and 3. So now, if they have a buddy beside them, that means that if there's a repeat, what we're going to do is at the end of all of these branches, so at the end, we're going to circle our buddies, and if they have an exit buddy, they can come outside of the radical. So notice how there's 2 2's right here? We're going to pull that out, and we're going to put it out in front. Anything that we pull out from the radical, it's going to be multiplied by whatever else is out there. So we're going to have 2 times 3 on the outside. Anything that's left that doesn't have an exit buddy stays inside the radical. So we're going to take 2 times 3. That's going to give us 6. And we're going to have the square root of 2 on the inside. Now there is another way that we could have possibly done this. If we would have listed out all of the factors of 72, we would have noticed that 2 times 36 is also factors. Okay, so if we do this again, we start at the top, we have square root of 72, and we break that down into factors of 2 and 36. Well, what are factors of 36? Well, we know that 36 is a perfect square. So that means that 6 times 6 gives us 36. And remember our rule, if we have an exit buddy or we have a pair, they can exit the radical. So that's going to give me 6 square root of 2. So those are the 2 different ways that we can do this. So this over here is called a factor tree. And this over here is simplifying by square root, or perfect squares. Okay, and either way is acceptable. If you're like, I don't remember all of my factors, and you want to just pick 2 that you know, you can break all of those down until you get to the point where you can't break it down anymore. For instance, are there any more factors of 3? Well, there's 3 and 1. but I can't break that down anymore. There's not going to be a perfect square that's produced from that. So once you get to the point where you only have 3 or itself and 1, then you have reached the end of the little branch. For perfect squares, once you figure out what the biggest perfect square is, then pull it out, and whatever you're left with, that goes underneath the radical. The only issue with doing perfect squares is you got to take the biggest one. Because remember, over here we had 9, which is a perfect square, and we pulled that out, but we could still break other things down. There was another perfect square that was inside. Well, what's 4 times 9? 36. That's how we would produce that biggest perfect square. So always make sure that you pull out the biggest perfect square from this if you're going to do it that way. Go ahead and pause the video, try number 2, and then you're going to check your work. Alright, so hopefully you worked it out one of these 2 ways and you got 6 root 7. You could do it either way. So this is the perfect square method, and this is the factor tree method. Okay, so with the factor tree, it's a little bit easier because, I'll be honest with you, I don't know the factors of 252. So I wouldn't probably have known that 36 was the biggest perfect square unless I just sit there in my calculator and type it in. So if you're ever like, I don't know how to figure out the factors, if you go into your TI-83 calculator, so in your TI-83 calculator, if you're like sitting there going, I don't know factors of 252, what you're going to do is hit this y equals button, and you're going to type 252 divided by x. Once you type that in, you're going to hit second graph, and that's going to pull up your table. On the left-hand side is one factor. On the right-hand side, there's another factor. So 1 times 252 gives you 252. 2 times 126 gives you 252. 3 times 84 gives you 252. So if I scroll down, I can just keep looking until I get the biggest perfect square, which is 36. So 7 times 36 would give me my factors. That's my biggest perfect square. And we know that the square root of 36 is 6. We'll pull that out. And whatever we're left with, we put underneath the radical. So that's just a little cheat code. Again, you're going to hit the y equals button. Ooh. Look at that handwriting. You're going to hit that y equals button. And then you're going to type whatever number you're looking for. So the number, and then you're going to divide it by x. You're going to hit second, and then graph, and that'll give you the table. And again, I would know this by heart. Please don't ask your teacher while you're taking a test, hey, how do you? No, you need to know this, okay? So this is your cheat code. Have it memorized. Okay, this gives you the factors for anything that's underneath the radical. All right, so take a moment and go ahead and try 3 and 4. And in about 10 seconds, I'm going to post the answers, and then we're going to kind of talk through them. All right, so on number 3, we know that 64 is a perfect square. And if you type this into your calculator, it's going to give you that answer. So, for instance, if I hit second x squared and type 64, close parentheses, and hit enter, I'm going to get 8. So, when in doubt, put it in your calculator, and if it gives you a whole number, guess what? You're done. On number 4, if we type this into a calculator, we're going to get square root of 320. We're going to get this long decimal. We don't want that. So, with that being said, we can do it either of 2 ways. We can do our factor tree, which is what we did up at the top. Okay? And yes, you can change up these factors. So, like, let's say you did 4 and 80. That's okay, too. So, if you break those down and you get the same output down here, all of the branches at the end should be the same. It doesn't matter what you have up here. Branches at the end should be the same. Now remember, we can only exit the radical if we have an exit buddy. So 2 and 2, pull that out. 2 and 2, pull that one out. And 2 and 2, pull that one out. So I have 3 pairs of 2's in here. And whatever's left, which is this 5, I'm going to put it inside the radical. So I get 8 square root of 5. Now if I sit there and I do my factors of 320, I'm going to realize that 64 is a perfect square. So if I take the square root of 64 and pull out the 8, I'm left over with 5 underneath the radical. One thing that I want to mention, one quick way to check and make sure that you've simplified it correctly is if you type in the original square root into your calculator, you'll get this decimal. And then take your final answer and type it into the calculator. So my final answer was that 8 square root of 5. I'm going to type 8 square root of 5. I'm going to hit enter. And if these two numbers match up and you don't have any more perfect squares underneath this radical, you did it right. So just one quick way to check it. All right, so I know how y'all love letters in math because, you know, mathematicians are awesome and we like to confuse people. So with that being said, on number 5, the first thing that you're going to do is ignore the letters. Okay, so we're just going to look at the numbers. So we're going to repeat that same process that we did on the last page. So we've got that square root of 96. So I'm going to go into my calculator and I'm going to hit that y equals. And I'm going to type 96 divided by x because I don't know factors of 96. Then I'm going to hit second graph. And that's going to give me all my factors. So I'm going to scroll through here. All right. So biggest perfect square. Well, 16 is a perfect square. So I can use 6 and 16. Okay, so 6 and 16. Now, can I break down 6? Yeah, into 3 and 2. Can I break down 16? Yeah, into 4 and 4. Well, 4 and 4, I can still break those down, but those are already buddies. So I'm going to go ahead and circle those guys and pull him out to the front. And then whatever's left, I'm going to multiply and put back into the square root. Okay, so 3 times 2 is going to give me 6. So if you're ever left over and you don't have an exit buddy, whatever's left, you're going to multiply it together and shove it back into the radical. Okay? All right, so now let's deal with that pesky little letter right here. Okay. So it says r squared. That squared is really, really important. When we do the square root of something, technically there's this little like 2 that's normally supposed to be written right here. But since we take the square root of stuff so frequently, we take out that little 2 and we just call it a square root. Okay? So if there is a 2 or nothing is written right here, that's awesome for us because when we take the square root of r squared, that's just going to give us r, right? If we took the square root of r squared, we're just going to get r. And the reason why is because if we break down r squared into factors, we're going to get r and r, right? And we talked about how if you have a pair, then you can pull it outside of the radical. So if there's an r and an r, we're just going to pull it out and put it out front. So our final answer is going to be 4r square root of 6. All right? All right, so on 7, because we're going to skip 6 really quick. On 7, what we're going to do is focus on that number first. So we're going to do the square root of 294. We're going to go into our handy dandy calculator, and we're going to type 294 divided by x because homegirl doesn't know her factors. So I'm going to look through and find my biggest perfect square. Well, I know that 49 is the biggest perfect square, so I'm going to use 6 and 49. Well, if I break 49 down, I'm going to get 7 and 7. If I break 6 down, I'm going to get 3 and 2. Well, I got exit buddies, so I've got 7, and these two guys can't exit the radical, so I'm going to multiply them back together, put them underneath. Now, let's talk about those variables. We've got v to the third power. Okay, so since we have v to the third power, this is, if I was going to put out a factor tree, I would get v squared and v, right? And if I broke that down, I would get v and v. Well, now I've got pairs. So I'm going to circle my pairs. I'm going to put one of the pairs out on the outside, and then I'm going to be left with the v on the inside. All right? So if it has an exit buddy, it can come outside the radical, and if it doesn't, it just goes back inside. So our final answer is going to be 7v square root of 6v. Go ahead and pause the video, and I want you to try 6 and 8 on your own, and then you're going to check your work in about 5 seconds. All right, so to check your work, anything that's in the blue box is your final answer. So if you have any questions on these, please see your teacher, or you can email me.